Here is another example of a triangular prism, and I'm going to demonstrate how to find the surface area of this triangular prism for my students. I have students in the room right now, and I'm looking around the room for all my active listeners. I'm trying to make eye contact with all of them because if they're looking at me, and I know they're paying attention. Okay, and hopefully they're not fidgeting with anything in their hands. Now it says here, is the triangle that forms the base of the prism equilateral, isosceles, or scalene? I'm going to use what I know about the definitions of those words to figure it out. I know that equilateral means all the sides are the same length. Isosceles means that two sides are the same length. Scalene means that all three sides are different lengths. And when I look at this one, I see it says 8 meters by 8 meters by 8 meters. So because they're all the same, they're all equal, this is an example of an equilateral triangle. Now it says write a numeric expression to represent the surface area of the figure. One of the things that I pretty much always do when I get ready to find the surface area of a prism like this one is I make a net. And I'm going to go ahead and make a net, and this time I'm going to try and make one kind of neat. I'm going to be a little bit neater about the net, and I'll make this little net here. Alright, so I know that I'm going to wind up with a this rectangular part here. And I know that it's going to have a rectangular part right next to it. And I know it's going to have another rectangular part over here. And let me try and get this to look better. Okay. Now I'm going to need to come up with this equilateral triangle here, and then they've got another one back there. So I'm going to go ahead and make one of those equilateral triangles. Let's see. Okay, so it's upside down. Let me pull this upside down triangle where I can use it. So I'm going to put it right here, and then I need another one up at the top. I need another one right at the top. Okay, so. Alright, so here I have a net that represents this shape here. Now, if I were to cut this net out and I were to tape it together, it would give me a triangular prism. Now this one looks like it's upside down, and this one looks like it would be right side up, but it doesn't matter. It doesn't matter. Alright, now let's go ahead and write down the dimensions. I know that my rectangle here is 8 by 4. This is 8 and this is 4. So I can say then that this is going to be 8 meters and this is going to be 4. And one of the things I want to point out, I had a student, he made a comment earlier when I was showing how to make a net, and he said it didn't look right. Like here, this looks like it's all equal sides on this rectangle. It's not drawn to scale at all. I mean, really, this should be twice as long as this side here, but it doesn't matter. This is just, you know, for me to keep my my surface areas together and not leave anything out. Now, this next one, it's going to be 8 by 4 as well. It's going to be 8 by 4. So I'll put 8 here, and it's also by 4. And then this one here is 8. And it also is 4. It's also going to be 4. Now, the dimensions for my triangles that I need to pay attention to, I have to have the base, which is 8, and the height, which is 3.46. So the height is what I really need to focus on too, not the side lengths here. So this is going to be 3.46 meters. And then here will be 8. And then the height would also be 3.46 meters. Now, I didn't bother putting my units of measure just to save a few seconds, save a little time, because this net is for me. It's not for me to have to turn in to anybody. It's just for me. Alright, B says write a numeric expression to represent the surface area of the figure. Well, I'm going to go ahead now and translate all of these into expressions that when I find the areas of each of those shapes, it'll give me the surface area for the entire shape. Now, I'm going to use a little bit of grouping here to help me. I have 3 rectangles that are 8 by 4. They're the same. So I'm not going to write 8 times 4 plus 8 times 4 plus 8 times 4. I'm just going to say 3, and then parentheses, 8 times 4 plus. And that's got this one taken care of, this one, and this one. Now I have 2 triangles. And my 2 triangles, they're both 8 by 3.46, half times 8 times 4.36. So I could say 2, and then in parentheses, but half times 8 times 4 and 30. I'm sorry, I made a mistake there. It should be 3 and 46. 3 and 46 hundredths. Okay, so let me back up just a little bit. Now I'll just have to work it out. So 8 times 4 is 32, and 3 times 32 is 96. Now I'm going to cancel these out, because when you have 2 times a half, that would be like 2 times 1/2. That's like 2 over 1 times 1 over 2. Those would cross cancel, and I'm left with 1 times 1. 1 times 1, and that's going to equal 1, and so I don't even need it here. I don't even need it, so I'm not going to worry about that part. I'm just going to think 8 times 3.46. Alright, so 3.46 here times 8, and I'm just going to work it out. Alright, 8 times 6 is 48. 36, 24, 27. 1, 2. So that would be 27 and 68 hundredths. Now I just have to add them together, and that will give me the surface area of the figure. So I can go ahead now and I'll put 96 here. So it's 123 and 68, and this is area, so it's meters squared. So this would be the surface area for the figure. Now I have students in the classroom. If I were to talk about math practices here, I use what I know about certain words here to pick out what type of triangle it was. I use what I know about how to find the surface area. I kind of made a model there with my net that I created. I did a whole lot of math practices. But what grade do I observe, children? Okay, you all sat very quietly. Now, you were sitting quietly, but that doesn't necessarily mean that you were actively listening, that you were actually paying attention here. Who can point out a step to me where it was different from what you got? Did I do anything different from what you did? All right, what did you do differently from what I did, Brenton?
Right there you said 2 times 1/2. I didn't know that.
Okay, so you actually went it through and did the entire formula here for finding one triangle, then you multiplied that area by 2 to get 27.68?
Yeah.
Okay. Well, this is just a little shortcut. As long as you get the right answer, I don't care the process that much, as long as it can be replicated. All right, anybody else do anything different from what I did? Okay, how many of you got it right? Okay, how many of you, as you were watching me work it out, those of you who got it correct, how many of you kept feeling like, yep, that's how I did it? Okay, I'm seeing those same hands up. Those of you who missed it, if I were to give you this exact same type of problem to do, find the surface area of a triangular prism, how many of you could do it? Okay, I'm seeing some hands up on that one. That's what it's all about, doing a demonstration, letting kids see how I work it out so that they can see what they need to do. That's the whole purpose. I mean, it is fun. I enjoy doing this type of problem. It is fun for me. It's just fun. You know, it's like a little puzzle trying to figure something out. But it's not much of a challenge for me, really. But it's fun, and I don't mind doing it for students. But I'd much rather you all show me how to do this. All right, Jerry, you have a statement or question?
If this was a real world problem, wouldn't you have to add the 1?
As long as I got the same answer, it doesn't really matter. I don't know what you're talking about, add the 1. I mean, there's not a 1 that I need to add. Are you talking about multiply this part here where I kind of took a shortcut?
Yeah.
No, even if it's the real world, like let's say for instance let's say that we had a playhouse or a clubhouse or something, and I was trying to figure out how much paint I needed to paint it, and it was shaped like this, and I were going to paint it all over. For some reason, I was even going to paint the bottom. Then I would work it out like this. I could find out exactly what the surface area would be, and then figure out how much paint I need to buy to paint it. So it doesn't matter the process really, as long as you get the right answer. You can have a different process, and this was just a shortcut. All right, I hope this helped y'all.